Hi, my name is Nicholas Espinal. This is the third question from my Chapter 28 quiz, and this is what it asks. A long straight conductor has a constant current flowing to the right. A wire rectangle is situated above the wire and also has a constant current flowing through it, as shown in the figure. Which of the following statements is true? If we look at our answer choices, you'll see that they started mentioning the magnetic force on the rectangle and the torque on the rectangle. So to answer this question, we're going to have to relate magnetic force and torque to the situation. And how do we do that? Well, looking at the figure and using the right-hand rule, we can identify the direction of the magnetic field lines by pointing our thumb in the direction of the current. So for the wire on the bottom, if we point our thumb in the direction of the current, our fingers will curl upwards to us, showing that above the wire, the magnetic field lines are pointing out of the page, and below the wire, they're pointing into the page. If you do this for the rectangle as well, you'll notice that through each length of the rectangle, the center will have a magnetic field pointing out of the page, and on the outside edge of each length for the rectangle, the magnetic field would be pointing into the page. And then we must also remember that the magnetic force is equal to the current times the length vector crossed with the magnetic field vector. So when we use the right-hand rule, we'll see that the magnetic force applied on the rectangle by the wire at the bottom is actually pointing downward. So we take the length vector and multiply by the current, and we know it's going to the right. And we also know that the magnetic field vector is pointing out of the rectangle. And then we're going to see that the magnetic force is actually pointing down towards the wire. And to address the torque, we'll need to understand the magnetic moment, which is also known as mu, of the rectangle. And this points out of the counterclockwise loop of the current. Since we're already looking at the counterclockwise loop of the current, it is going to be pointing toward us. And we'll also need to remember that the torque is the cross product of the magnetic moment and the magnetic field, which also means that if they're pointing in the same direction, the direction is what is represented from the cross product. If there's a large value, that means that they're as furthest away in direction as possible. But if they're in the same direction, the torque is going to be 0. So in this case, since the magnetic field and the magnetic moment are both pointing towards us, they're both facing the same direction, the torque exerted on the rectangle is 0. So if we look at our answer choices, the downward force and the 0 net torque is going to be the third answer choice. Thank you.